Orca is a large language model from Microsoft. And why is it special? Okay. So this is a 13 billion parameter model. It tries to imitate the reasoning process of large foundational models. Okay. So there has been recent research which is focused on enhancing the capability of smaller models through imitation learning, drawing on the outputs generated by large foundation models like ChatGPT or GPT-4. So number of issues impact the quality of these models, ranging from limited imitation signals from shallow LFM outputs, right? Small scale homogeneous training data, and most notably a lack of rigorous evaluation, resulting in overestimating the small model's capability, as they tend to learn to imitate the style but not the reasoning process of large foundation models. Okay, now what does all these things mean? Let's go into the details. Okay, so let's go into the introduction, right? So what they are saying is that ChatGPT and GPT-4 has remarkable zero-shot performance across a broad spectrum of tasks. Okay, which could be against academic benchmarks, but also human level performance on various professional exams like SAT, GRE, bar exam, USmile. Okay, so this is because of scaling of both model and data set sizes, as well as you have second layer of training, which is could be either through reinforcement learning, right? The fine alignment which happens. Okay, so these models are becoming more and more powerful. So can we use this model to supervise its own behavior or that of other AI models? Can we use as these models continue to evaluate? Okay. So what is happening is that there has been an influx of studies using models like ChatGPT and GPT-4 as teachers to generate large data sets for instruction tuning, and then to train smaller models on these data sets such as Alpaca, Wizard LM and Vicuna. So these models are smaller models which have been trained on data generated from these larger models like ChatGPT and GPT-4 via instruction tuning. Okay. So these models can provide content that match the style of their leaders, but they often fall short in terms of reasoning and comprehension skills displayed by the larger foundation models. Okay. So that is what is the key issues. Okay, with the smaller models which have been trained on data generated from larger models via instruction tuning. Okay. So the current research on instruction tuning to mimic the output of exhibits notable limitation in terms of task diversity, query complexity and data scaling. Okay. So if you want to match these larger models, then you need to have a lot amount of data and you need far diverse and higher quality imitation data. Okay. So what they are saying is, contrary to this assertion, they are demonstrating that both these conditions are attainable and it is possible to reduce the gap with proprietary LMs on multiple zero-shot benchmarks that require sophisticated reasoning. Okay, so there are two challenges. One is simple instructions with limited diversity. So all the current instructions which are generated for instruction tuning, okay, they are quite simple and they are with limited diversity. Okay, and other thing is that task diversity and data scaling, you need to have lot of tasks and data to actually learn from it. Okay, and limited imitation signals. Current the teacher models like ChatGPT produces an output and your smaller models tries to learn from it. Okay, so only query and response is available from the pair generated by the teacher model. Okay, because these are closed large language models, you are just looking at the response and from that you are fine tuning. Okay, smaller models, right? And to evaluation also happens on only like say the smaller models, evaluation is done on the basis of GPT-4 as a judge, like Vicuna and Wizard LM. These models are using GPT-4 as a judge. Bias could be present. GPT-4 could have biases, right? It could prefer shorter response over longer responses. So it is not a good evaluation methodology. So what are the key contributions of this paper, right? So the key contribution is they do something called as explanation tuning. Okay. Before going into explanation tuning, let us look into what is instruction tuning and then come back to explanation tuning. Okay. So instruction tuning is a technique that allows pre-trained language models to learn from input. So natural language description of the task and response pairs. For example, this could be an instruction: arrange the words in the given sentence to form a grammatically correct sentence. The input could be the quickly brown fox jumped, and the output is a brown fox jumped quickly. So it learns from this kind of a data. Okay. So this is, say, instruction tuning with GPT-4. Here are some examples. Given user instructions for a task and an input, system generates a response. For example, user instruction could be like, right, use the given data to calculate the median, and input is this. Output is, first we need to arrange the data, right, in ascending order. Since there are 5 numbers, the median is this. Okay, so this is the instruction fine tuning methodology. Okay. Now what is explanation tuning? Alright. Now explanation tuning is what they have proposed in this paper is they augment the query response pairs with detailed responses from GPT-4 that explain the reasoning process of the teacher as it generates the response. So basically you are actually asking GPT-4 to explain how this response got generated. Okay. Now how can you do that? You can leverage system instructions like explain like I am 5. Think step by step and justify your response. Right. So you can give such instructions in your system instructions, and you can get more information in the reasoning and the outputs. Okay. Basically the reasoning of these bigger models like GPT-4. Okay. So this is where you have system instructions which come into place. So for example, in GPT-4, you could have a system instruction like, right, you are an AI assistant. User will give you a task. Your goal is to complete the task as faithfully as you can. Use the given user instruction is use the given data to calculate the median. Input is this. The system instruction can be specified in the API, and user instruction is user's output, user's input query basically. And then you give the input. Then what it gives detailed expressions like this. To calculate the median, I will follow these steps, because in the instruction you are asking that while performing the task, think step by step in the system instruction, and it gives detailed responses like this. Okay. So now their idea was to use these detailed responses along with this system instruction and user instruction, and then fine tune a large language model based on llama. So this is what they call as explanation tuning. Okay. And what they did was they constructed in their dataset, they constructed the following kind of triples: system message, user query, and large foundational model response. System message placed at the start of the prompt provides the large foundation model with essential context, guidelines, and other pertinent details. They leverage system message to vary the length of the response, outline the assistant's character, establish acceptable and non-acceptable large foundation model behavior. The user query defines the actual task we want the LFM to perform. Okay. So that's what they did over here. Right. So here are some system messages which they crafted. Okay. There are close to some 16 messages over here. One example is this: given a definition of a task and a sample input, break the definition into small parts. Each of those parts will have some instruction. Explain their meaning by showing an example that meets the criteria. Use the following part. Key part is key part of the definition. Usage is sample response that meets the criteria. So these are different kinds of system instructions. Okay. You are an AI assistant that helps people to find information. User will give you a question. Your task is to answer as faithfully. While answering, think step by step and justify your answer. Okay. So what they did was they did data set. They created data set from FLAN v2 collection. I'll not go into the details of this over here. Right. You can read through, but the idea is this. Right. If you are in the data set, if there was this thing, right, you are an AI assistant, pick which sentence is not logical, and this was the answer. Right. But what they did was, instead of this human, instead of this gold answer, okay, this is the gold answer for this particular task, right? What they did was they asked ChatGPT to explain for this particular query, and they got this particular response. Okay, much in detailed response which shows the reasoning of ChatGPT, and similarly from GPT-4. And then they created tuples where you have the system, triples where you have the system instruction, where you have the user query and then you have this response, okay, for fine tuning. But then they created two kinds of data set, okay. That is another thing which is interesting over here. Alright, they generated 5 million instructions, queries augmented with system message referred to as FLAN 5 million, and they randomly sampled 1 million queries from FLAN to create another split FLAN 1 million. They used ChatGPT to generate responses for FLAN 5 million and GPT-4 responses to FLAN 1 million. Okay, so they first trained Orca on FLAN 5 million ChatGPT augmentations, followed by second stage of FLAN 1 million. This they call as progressive learning. Okay, they use ChatGPT as an intermediate teacher assistant for two reasons. So ChatGPT, what they're saying is that first, Orca with 13 billion parameters is much more smaller than GPT-4. So leveraging intermediate teacher with reduced gap in capabilities, in this case ChatGPT, has been shown to improve imitation learning performance. So this is what they call as progressive learning. So when you are learning as a student, you move from easier examples to harder ones. So they trained, their idea is that they first trained on 5 million easy examples from ChatGPT, and then they moved to 1 million basically on GPT-4 augmentations. Okay, the idea over here is GPT-4 augmentations, GPT-4 explanations are much more difficult than ChatGPT explanations. Okay, maybe it gives more detailed explanation compared to ChatGPT. That's what they did over here. So they fine-tuned on first, ChatGPT augmentations FLAN 5M dataset, and then on FLAN 1M GPT-4 augmentation. So two-stage training was done. Okay, that's how they did it. Right. I won't go into further details of this paper, but what could they achieve by this? Right. What results were achieved from doing like this, training like this with reasoning data set, right, where they created this system instruction, this triple pair of system instruction, then user query, and then the response from ChatGPT or GPT-4, right. When they trained on this data, what they observed was that they could get very good results, right. Let's go to the results. Say for complex zero-shot reasoning tasks in big bench hard, say Vicuna achieves only say 23.3% accuracy, whereas Orca 13 billion is much better than ChatGPT, which is a much higher scale model in terms of parameters, right. So smaller model trained in this particular way, whereby it is trained on traces of reasoning from larger model, gives performance equivalent to larger size models, larger size foundational models. Okay, this is another thing where they're saying that on professional and academic exams, where Orca is giving almost performance equal to TextDaVinci 003 and quite close to ChatGPT. Okay, it does much better than Vicuna over here, right. So this smaller model bridges the gap with OpenAI foundational models like TextDaVinci with 5 points gap to ChatGPT. So this is what the performance they could achieve with the smaller model. So that is the key insight over here. Okay. So they discuss various shortcomings also over here. Right. I wouldn't go into it, so probably you can read through it. Right. But let's look at quickly at one or two examples of case studies. Right. So this is trigonometric problem solving. So system is, you are an AI assistant that follows instruction extremely well, help as much as you can. So this is a question: given that the hypotenuse of a right angle triangle is 13 and the ratio of lengths of two legs is 5:12, find the lengths of the two legs. Okay, so hypotenuse is the sum of squares of the length of two legs. So you can use this formula. It gives step-by-step evaluation and it gives the final answer, which is correct. Whereas Vicuna fails for this particular problem, and ChatGPT gives a proper response. Okay, GPT-4 also gives a proper response over here. If you look at the kind of explanations GPT-4 gives, it gives a much detailed explanation compared to Orca, right. But this is also fine, right. Like this, they have given examples for the various use cases, right, on which Orca performs well compared to other models, and there are also explanations where Orca also fails. So these examples are nice to read and understand more about how this model performs. Okay, so for example, this is a bio Olympiad question, right? Here, while answering things step by step and justifies the system, and here, woman experiencing rickets is diagnosed with the deficiency of a particular vitamin and given a diet guideline. Which of the following food is likely to help with the condition? So it has to actually explain. So it says ricket is primarily caused by a deficiency of vitamin D. Now let us analyze the given food options. Carrots are not significant. Butter does contain but not significant. Tomatoes are not significant. Oranges are good source of vitamin C but not vitamin D. Whole grains are not a good source. Based on analysis, none of the food options are significant. However, among the options, B is better. Additionally, she should also consider getting more sunlight. So it gives a very good explanation, whereas Vicuna kind of fails over here, right? It gives, therefore the correct answer is D, oranges. So ChatGPT also kind of fails over here, right? Whereas GPT-4 gives a good answer over here. Okay. So in this way, this kind of training a smaller language model, okay, on training data which is generated using reasoning, right? Basically reasoning from a larger foundation model gives performance which is quite closer to the larger language models, right? That is what is kind of an insight from this paper. Okay, so I'll be putting the link of this paper in the description of the video. You can check it out. So currently what they have written over here is that they are working with their legal team to publicly release a difference of the model weights in accordance with the Llama's release policy. So this is not sure. This is a work in progress when they will release the difference in weights from, because this is based on Llama. So the difference in weights is what they will publish. I don't know when it's going to happen, but that would be interesting to see once it is released. Okay. I hope this video is useful for you. If you like the video, please like, share, subscribe to the channel. See you in another video.